So next up is Melissa Rhodes from Argonne.
The goal of the campaign is to support a first-of-a-kind MSR being built in the next 10 years. And so at Argonne, we are trying to align our activities to support that by generating data and developing the technologies that will be needed to design, license, and operate MSRs. So we have a variety of activities supporting that. We're, of course, making high-quality measurements of molten salt properties and developing standardized measurement methods to support that, as well as performing salt spill tests to generate data for accident scenario analysis, and developing sensors for chemistry control and a molten salt test bed to validate them. As Patricia pointed out, we must validate all of our models. And so specifically this year, we focused on, in the chemistry space, thermal properties of molten salts with and without fission products to understand their effect, generating that data to support accident scenario analysis and technologies for monitoring chemistry. With all of our activities, we actively engage with industry to make sure that our activities directly address the needs of MSR developers. We do this by coordinating our campaign work with our GAIN voucher work, NEAP-funded work, and direct funded activities that we do with developers. We host regular discussions to enhance collaboration between national labs and their stakeholders, and we're directly coordinating with our colleagues at Oak Ridge, Tony Beery here in the front, on incorporating new data and quality assessments into the molten salt thermal database. This is our shameless plug for Argonne, all the different things we can do for you. So we have expertise and capabilities in thermophysical property measurements, materials compatibility and corrosion studies, electrochemical monitoring and control of salt chemistry, and of course, linking all of that together to gain an understanding of the fuel cycle for these reactors. We have a radiological facility which houses a suite of purpose-built inner atmosphere glove boxes, which can measure salts containing actinides, beryllium, and even simulated fission products to examine thermophysical behavior without the need for irradiation. And then we have glove box furnace wells everywhere from 6 inches in diameter all the way up to 36. So we can't even go to engineering scale. Our furnace capabilities go up to 800 C in those glove box wells, but we also have induction and resistance furnaces for higher temperature work. And this is just a photo of our thermophysics property laboratory and the team in front of one series of our glove boxes. As far as property measurements go, we have an ever-growing list of capabilities. I'm not going to go through each of them, but I will say that we do have a world-class analytical chemistry laboratory which supports us, allowing us to have compositional analysis for major, minor, and trace elements, including dissolved oxygen in our salts, and that's key to the quality of our measurements. Also key to the quality of our measurements is the development of standard or reference measurement methods. So we have taken all of our measurement methods and proceduralized them in a way that generates records suitable for NQA1 qualification of our results to help with licensing. We are actually leading a task group on standardizing our rotational viscometer method, which started at the ASTM meeting in June this year. And Levi, who is also here, will be giving a poster on our efforts to standardize that method this afternoon. We also host tri-weekly MSR chemistry discussions to enhance collaboration among the national labs and some universities on these molten salt measurements for properties. In the center, you can see Levi demonstrating our rotational viscometer method, and the other photo is our laser flash analyzer for measuring thermal diffusivity. So the chemistry work this year, like I said, focused on the effect of fission products on molten salts properties. We prepared doped versions of salts we'd previously measured so we could compare the change in properties. We did a sodium uranium chloride salt with cesium chloride and cesium iodide dopants, specifically to look at the effect of cesium and iodine. And then we did FlyNet with 2 variations, a low burnup and a high burnup composition. These are inspired by MSRE depletion calculations, but are not exactly, item for item the same. We did use these same salts in the salt spill testing that Sarah Thomas did, that Patricia talked about. Sarah Thomas is also here. She'll be giving a poster this afternoon as well, so please talk to her about that, but I'm going to give you a preview of her work in a minute. But we looked at these salts. You can see in the photos here, the appearance of FlyNet certainly changes as we dope it with the fission products, going from a beautiful pure white to a dark gray. So we wanted to see how that affected properties. The specific properties we looked at this year are thermal behavior, heat capacity, and thermal diffusivity. And we'll continue this work in the next fiscal year, looking at some more macroscopic properties like viscosity and density. So the good news is, thus far, the fission products appear to have only a very minor effect on the thermal properties at the concentrations that we studied. That's sort of demonstrated in the data here on the right, right, left, you know where it is. So you can look and see each of these are measured thermal behavior of salt samples in gold cells by differential scanning calorimetry. So we're looking at the position of the onset of melting and the liquidus temperature. Those are marked by the dashed vertical lines. And you can see as we dope the salts, those move to slightly lower temperatures. So and we're also getting additional transitions at lower temperatures indicated by the arrows. But again, the effect is very minor, which is good news for those of us designing reactors, and we want our fuel properties to stay where we want them to. This is good. And we also, I don't have the images here, but it does not have a measurable effect on heat capacity or thermal diffusivity either. This report cited at the bottom is available in OSTI if you would like to look at the full work. And now I'm going to talk about that workshop Patricia mentioned earlier. We had a workshop addressing uncertainty in molten salt thermal property values and predictions this year. Patricia and I discussed and were concerned about how we were going to quantify uncertainty in several areas, in the measurements themselves, as well as in predictions, and then how to quantify the consistency between our measured values and the predicted values. And how will we roll all of that up into a quantified uncertainty in a system model that relies on several different properties. So the workshop report is not completely released yet. I'm still waiting on permission to use a couple of figures, but these are the general recommendations from that report, that we continue to apply transparent, thorough, and documented QA processes to our databases so that they will be available to the developers as they use those. And we want to quantify the uncertainty in those model predictions where we need them to bridge data gaps, and use of Bayesian statistics where recommended. We want to generate a series of standardized methods of measuring properties, and to support that, identify and produce a standard reference material that researchers can use to quantify the accuracy of those measurement methods. And lastly, it's very important to continue promoting regular interactions between modelers and those measuring the properties to ensure that when specific data needs are identified, like those Patricia showed from TED, we can be sure to measure those and reduce the overall uncertainty. I'm going to move into other people's work now, so be kind with the question. But this is a summary of Sarah Thomas's salt spill work. So the objective of her work is to provide the data needed to close gaps in our understanding of the mechanistic source term and accident progression models for licensing in MSR. She conducted integrated process tests that simulated a molten salt spill accident at a laboratory scale to generate that data. This schematic is showing the scenario she simulated in the lab. So the idea is that there's a break in a pipe and salt pours out onto the containment floor. And what are the different processes that happen, and how can we quantify those? So specifically, she focused on heat transfer from the spilled pool to its surroundings, the catch pan, the environment, and how did that change the composition of the salt as it interacted with its environment, and what were the composition and size of aerosol particles generated. So again, she has a report cited at the bottom here, but she's also here if you want to chat. So I'll move on to Nathan Hoyt's work, who you've heard his name earlier as well. He has done some really great work at Argonne developing a molten salt technology testbed. So we have several flow systems, purification systems, and large-scale vessels that together act as a testbed for technology development. They're highly modular and engineering scale, and they allow us to test a wide variety of new technologies, including process monitoring, process control, safeguards, corrosion studies, all in this facility. So these systems are actually installed in large-scale glove boxes, which allows for straightforward operations with actinide-bearing salts, as well as rapid reconfiguration of the system if we want to change pipe diameters, introduce new test sections. That is very easy to remove and install in that glove box space. Additionally, these systems have been fully automated, which allows for long duration salt testing and testing conditions to be varied across thousands of different permutations, and just a faster generation of the data we need. Nathan has also spent considerable time over the last several years developing sensors, which he is testing in his test bed, along with other folks' technologies. But specifically, he has testing capabilities to implement in flow loops, purification systems, and process vessels. And he has deployable sensors measuring composition, redox state, and particle concentrations, some of which are pictured here. And the last thing I want to bring up is the workshop that Patricia was telling you about earlier. We hosted an MSR fuel cycle chemistry workshop at Argonne last month to support NE43 in developing fuel cycle technologies for MSRs in advance of their deployment. The idea was to identify what were the technological gaps and future research directions in both the front end of the fuel cycle, synthesizing and supplying and qualifying fuel salt, as well as the back end, recovering and recycling actinides, purifying and recycling salt, removing insolubles, and of course, safeguarding all of those fuel cycle facilities. So there will be a report on this issued in December. We had really great participation, and I'm sure a lot of the participants are here and would love to chat with you about how that went. So lastly, I'd just like to summarize by saying that Argonne is supporting the development of MSRs through our activities in making high quality measurements of properties, standardizing our measurement methods, generating the data needed for accident scenario analysis, and developing sensors and a test bed to validate them. I'd like to thank the Office of NE for their support. Are there any questions?
So it sounds like you have semi-frequently like an online forum that you talk to people, like a web conference or something. How do you get on the mailing list for something like that to participate?
We have a tri-weekly discussion that is very narrowly focused. That's national labs and MSTVB developers are invited to that. I don't believe we right now have a forum that's more open, but we could certainly develop that. Yeah.
Yeah, good. Because I'm very busy, I'm trying to have every 3 or 4 weeks meetings with the different tasks that I explained. We could expand maybe every thank you. We could expand every 2 months with others who may be interested, of course.
So I'm a part of Sandia, so does that mean I can be?
Yeah, we can
part of
probably
it?
get you on there.
Super.
The databases and the results are fantastic, especially if you're new to the MSR world. Is there a roadmap to provide reference samples of salts, kind of like NIST does for different standards, reference standards for people to use?
As far as a roadmap document, I think the last one that was put out by Jake, who is here somewhere. And so we haven't done an updated roadmap since then. Perhaps that's an activity we could look at for the campaign.
Brandon Wilson at TerraPower. I saw that you're working with ASTM to standardize viscosity measurements. I know that ANL has been doing, working on developing heat capacity measurements and other things too. Has any plan to work with ASTM to standardize other measurement methods for molten salts? Yes,
we plan to standardize all of them, and we encourage folks who are using different methods than us to standardize theirs as well. We really want to have a variety of standards that we can all use and just know that we're all applying them in the same way.
Do you have any idea how long that takes to happen?
Yeah, it's a long process. Yeah, 3 years to do one.
Just very good at funding.
Right.
We are starting with NISA and the others advice them.
I'm sorry, 3 years. It takes 3 years. We have very little funding, so they do that kind of on the side. I think I give you just 100K, huh?
Oh,
even not. So you see what I mean? And there's a lot of different thermophysical properties which should standardize. So.
This
Yeah.
person is looking for the reference for the dope salt property work on OSTI, ANL CFCT 2023.
So my publication release, people told me it should have been released yesterday, but perhaps it has not. So I will double check on that.
And there was another one. Who do we reach out to for a copy of the MSR fuel cycle workshop report? Okay, that's you.
Yeah. So reach out to me and I'll make sure you get a copy when it comes out.